We have our first keynote topic is test automation of microservices in the today's age of digital banking Darwinism. We have Rudolf with us. He's a seasoned IT professional with rich 30 years of experience. He's also a passionate tester. He's an agile engineering coach with Raiffeisen Bank International. He's a very well-known speaker and author who has participated in OOP Agile Tour German Testing Day. He also organizes Agile Test Automation Meetup in Vienna, which attracts around 1,100 members every year. Rudolf, a very warm welcome to you, and we are very excited to hear you.
Yes.
Audience, if you're interested to connect with him, you can always connect with him on LinkedIn. And over to you, Rudolf.
Sorry, can you repeat that?
Yeah, over to you. You can take over from here. I will be.
So first, second, I have to share my screen.
Yes, we can see you.
Yes, so this, and then I have to move to this one. And yes, my control screen say, yes, you can see my screen. So I guess I have 30 minutes, so I have to set up my clock. So, and so here we go. So, good morning, ladies and gentlemen. So, welcome to the API Summit and to my talk about test automation in the age of the digital banking Darwinism. There's something wrong, sorry. So, it's better. Okay, so Darwinism, you know, the theory from Charles Darwin that not the strongest survive, furthermore, they who can adapt faster. In fact, currently in the banking industry, only the banks survive who adapt their services faster than their competitors and bring these services to the digital banking market. But what is necessary to do that? You need three things. You need the cloud, you need microservices, and you need a mobile banking app. And of course, you need the right test automation strategy. Hi, my name is Rudolf, and I will tell you today something about test automation for microservices. So, who am I? Why I can talk about this topic? As I said, my name is Rudolf. I'm an Agile engineering coach at Raiffeisen Bank International in Vienna, Austria. And together with my colleagues from the Agile Engineering Support Department, we are helping the RBI product teams in the area of test automation, CI, CD, and DevOps. In addition to my work as Agile Engineering Coach, I'm the organizer of the Agile Test Automation Meetup Vienna, and I'm hosting 8 times per year the Test Busters Night Vienna. And last but not least, I'm writing articles about test and test automation for IT magazines. Before we start, one slide about Raiffeisen Bank International that you can better understand the context of my talk. Raiffeisen Bank International, short RBI, is an Austrian banking group. RBI operates a banking network in Central and Eastern Europe and covers 17 markets and serves more than 16 million customers via roughly 3,000 branch offices. And the RBI headquarters is in Vienna. So let's start with an introduction of the RBI Group Digital Solution Program. 4 years ago, RBI started with the Group Digital Solution, a program, in order not to miss the digitalization of the banking industry. Due to all the new kids on the banking block, better known as fintechs, companies like Inkdiba, N26, Monzo and Co., who now offered all the banking service via the internet, it was necessary that we as a traditional bank do the same. Imagine what does it mean for your business if your competitor makes it possible to open a bank account on a Sunday within 15 minutes via the internet. That's a nightmare for us. We need 2 hours and you must come to us in the branch. Shades of Charles Darwin. Our answer to handle this nightmare was the Group Digital Solution Program, short GDS. The goal of Group Digital Solution was to offer a new banking platform in the cloud called Merlin, an open banking API platform called Galileo, and a new banking channel via a native mobile app called MyRaiffeisen. MyRaiffeisen, the mobile banking app, covered in phase 1 only Hungarian and Romanian market. With Group Digital Solution, new technologies and approaches such as Amazon Cloud, Microservices, REST APIs, DevOps, continuous testing came into the bank. Therefore, the topic of software testing, whether manual or automated, had to be redesigned and implemented from scratch. Let's take a look at the challenges of microservices. Until GDS, we in RBI had only big, fat, monolithic applications. The rollout cycle was 2 to 4 times per year. With Group Digital Solution, we got a lot of microservices running in Docker containers in the Amazon cloud, which can be accessed via REST APIs from inside the company and from outside the company with every web browser and every mobile device. Microservices have the industry buzzing. Why? Think about faster release cycles. Think about the ability to take services on and offline without affecting the entire application. And think about the agility to keep up with customer demands. The test strategy for this microservice architecture must cover different topics like Docker containers, Amazon Web Services, REST APIs, API gateways, mobile apps, mobile devices. In this talk, we only take a look at the functional tests of the microservices and the tests of the mobile devices. Details about performance testing and security testing are out of scope for today. Here you can see the simplified Group Digital Solution architecture. We have the front-end layer for web and mobile. Then we have the API layer. Then the Merlin layer where all of our microservices and components are running in Docker containers. And last but not least, we have the back-end layer with our API gateway to access the network banks in Romania and Hungary. You can imagine that the microservice architecture is more complex than monoliths, or let's say it is complex in another way. There are 3 key differences that affect your testing strategy when you're dealing with microservices. First, interconnectivity. A microservice application can have hundreds of individual microservices spread across different machines. These services must communicate across the network in different ways. Testing this communication, the error handling, and the resilience is here a challenge. Then second, we have independency. Each microservice needs to be independent, so it delivers a single functionality and can be deployed in a different, and can be developed in a different technology. Independency means that each service could be replaced, managed, or deployed without affecting the entire system. And then we have scalability. Microservice abilities like concurrency, performance, and resilience are usually handled by scaling the microservice. That means running more instances of a microservice in parallel. Here we must consider concurrency testing to check how the system will hold up if all the services are used at the same time. Scalability is a powerful advantage of microservices and must be considered in your test strategy. So let's have a small quiz. Which object has to be shown on at least one slide at each test conference? Yes, you are right, the test pyramid. The test pyramid should not be missing at any test conference. But keep in mind that the pyramid is only a model, and the original pyramid was a great model for testing monolithic applications, and there we have 3 layers. 3 layers are enough. Now, with microservice, we have another pyramid. Now we have 5 layers. And for the effective test approach of microservices, we should bear in mind that the overall system and isolated microservices works as expected. Let's start with the unit layer. At this level, we verify that the core function works correctly in isolation from external references. Here we are checking that we have built the system right. We test the methods and the classes of a microservice. Then we have the service layer. Testing at the service layer dives deep into all functions within the microservice in isolation with mock dependencies. In addition to the functional tests, here we already tested some non-functional things like performance and security too. Next, we have the service integration tests. With these tests, we verify that our microservices works in conjunction with databases, messaging system, and other microservices. These tests are tricky since you have many independent services communicating with other independent services in many ways. This could be synchron or asynchron. Service integration testing verifies that a set of microservices delivers a feature. How we organize this in our testing? We collected microservices to a bounded context. We called it a cabinet, and verify that the cabinets are working together as designed. Here we test the main path, the negative path, and our edge cases. What happens if a service dies? What happens if a bit of a component, for instance, a Docker container dies? Things like that. Now, let's take a look at a special type of integration tests which had been forgotten for a long time and only come back on the stage through microservices. Let's talk about consumer-driven contracts. At the API layer, we test that the API works correct with the microservice, especially when services and API are made by different teams. The risk for misunderstanding in the expected behavior is high. Where the API and the microservice was developed by the same team, the standard API tests were sufficient enough. Sorry, what's happened there? Okay, so yes, where the API and the microservice was developed by, oh, come on, what's going on my screen? Sorry. Normally I work on a Mac and now on a Windows it is not the same. So when the API and the microservice was developed by different teams, we had a lot of issues since the country teams, in our case Romania and Hungary, sometimes provided the data not as specified or changed the interface without information. Therefore, we decided to use consumer-driven contracts to test the Merlin connector. The Merlin connector is our API gateway to the microservices of the countries and to their backend systems. Consumer-driven contract testing is a technique where the consumer defines the contract. The verification, the test itself, is then executed against the contract at the provider side in their software development life cycle, in our case in Hungary and Romania. We are using contract tests to ensure that interfaces between the provider and the consumer are implemented correctly. Finally, at the top of the pyramid, we find ourselves with end-to-end tests, where a test scenario maps to a customer journey. A test scenario verifies that the system as a whole meets the business goals. That's why, as much as possible, we try to keep the test boundary here as the fully deployed system and accessing it through the UIs, in our case, through web browsers and mobile apps. Our biggest challenge here was the provisioning of the physical mobile devices, since we needed more than 30 different devices. Now, let's take a closer look at test automation, at our test automation approach. This is a picture of our delivery pipeline, where you can see 5 test stages. We have development, we have system test, we have system integration test, we have the user acceptance stage, and we have production. And the goal of the teams was to deliver the software from the commit to production within 15 minutes. Take a look at the development stage. The development stage is the first stage where all code will be integrated and tested in a central point. Again. The goal here is to check that the feature works correct in conjunction with other features. All data source, as data source, we use mocks with synthetic data. Here we are executing the main user journeys against our RBI in-house mobile device lab, where we had one iOS and one Android device. Then we have the system test stage. Here we check that the software works correct for all user journeys on all mobile devices. The data here comes from our virtual bank. The virtual bank is a set of centralized mocks which are serving selected pseudonymized datasets. Here we are testing the interoperability of our mobile devices, and we executed all of our user journeys in an automated way. And this was the standard journey, the alternative journey, the exception journeys, the negative and the misuse journeys. And these tests we executed against our cloud device lab with more than 30 mobile devices. Now we are at the system integration stage. This is the first stage where we are connected to the countries and their microservices and the legacy backend systems. The goal here is to verify that we get the data from the backend systems via the APIs. We also want to verify that the exception handling in case of connection errors works as designed. And here we are using pseudonymized data from the system integration environments from the network banks. We are executing here some automated user journeys. In our case, this was the standard journey and every error case against our RBI in-house mobile device lab. And then we are at the user acceptance stage. Here we are connected to the country, to Romania and Hungary, to the UAT systems with pseudonymized data. At this stage, we did a lot of manual tests, scripted and exploratory testing, which was executed by business users with their private devices, partly into the wild. Into the wild means at home in the subway, in the train, on the road. Last but not least, after a blue-green deployment, we did only some smoke tests with the most important user journeys. This was the registration, the login, check account, and transfer money. And these tests were executed by beta users. As beta users, we had 10 RBI employees who own an RBI account in Romania or Hungary. After a successful smoke test, we did the full deployment. This speed was only possible with automating almost everything. And now we talk about our test tools, test automation tools, which we use. And when we talk about test automation, we had two types of test automation. We had test automation for the application code and test automation for the infrastructure code. That means we also checked our Amazon instances, our EC2 servers, our Docker containers, and so on. Due to the fact that we developed Spring Boot microservices, we used for the unit tests the Spring Test Context Framework. For the service tests at the service layer, we use Postman and Rest Assured for the functional tests, Gatling for performance tests, and OWASP ZAP and OWASP dependency check for security testing. At the service integration layer, again, we used Postman and Rest Assured. For the infrastructure side, we used always Inspec and Molecule. And then we are at the API layer, where we checked our consumer-driven contracts. Our consumer-driven contracts, as a tool, we use Pact. For the rest of the test, we use Postman, Rest Assured, and Gatling. And then we are at the top of the pyramid, where we run our end-to-end tests from the mobile devices. And this, for this, we use the framework, the Appium framework. So now we come to the more practical part, and I will show you how we organize our mobile device lab. To cover 80% of the mobile devices which are used in our target markets, we needed around 30 devices. The maintenance of such a huge set of physical mobile devices is a challenge. We decided to have two device labs. On the left side, you can see our on-premise device lab, where we had one iOS and one Android device, and they were always available for smoke tests. On the right side, you see the UI of our cloud device lab, where we use the mobile device cloud from South Labs with 30 private and more than 1,000 public mobile devices. And now you will see the setup, how our pipeline executes the tests. First, we have our self-developed orchestration tool, which organizes all the artifacts of the product, and which gets triggered by a commit in the repository. Then the pipeline starts with the build of our product and store all the artifacts in our artifactory. Afterwards, we deployed everything to the first stage, which is located on an EC2 instance in the Amazon cloud. As a next step, we prepare the South Labs environment and execute the tests. Therefore, we must create a secure connection to South Labs with the South Connect proxy. The South Connect proxy is a built-in HTTP proxy server that opens a secure tunnel connection for testing between the South Labs virtual machines or real devices, and the website or mobile app behind a corporate firewall. As a next step, then we deployed our native Android and iOS app to our internal app store. This internal app store was connected with South Labs, and South Labs patches the new app if there is a new version available. Now, our app is available in the South Labs environment and can be used for testing. In the next step, we fetches all the test artifacts from Artifactory and set up the execution stage with the test cases, the test suites, and with the list of our needed devices. And afterwards, TestNG executes our Appium tests in the South Labs environment where a Selenium grid is running and orchestrates everything. And this grid starts all the devices from our list, which we need for a test run. And at the end, all test files, the test results, the videos, the log files will be stored on an EC2 instance, which acts as a reporting server where the results can be accessed for further investigations. So, you know the saying, a picture is worth 1,000 words? Now, I will show you more than 1,000 pictures, which means I will show you a video where you can see everything in action. So in the first step, we did a smoke test and verified that all the connections and the South Labs environment is working. It is like a health check. And then after the health check, we started all of our tests in parallel. So back to my slides. So we are at the end of my presentation. Now my last slides. We learned a lot in our group digital solution program in testing a microservice architecture. And on my last slide now, I show you our top 5 lessons learned. Number 1, use microservices only if you really need microservices. Microservices are great, but you must deal with a lot of other things which are hard to learn and to do. Going the microservice way only because it is hip is the wrong approach. Number 2, use non-functional tests at microservice level. Start with testing of non-functional features already at microservice level. This is possible, believe me. Yeah? You can execute base checks for performance and security tests at microservice level, and then you can go up to the top of the test pyramid. Number 3, use consumer-driven contracts. If your microservices and APIs are developed by different teams, then use consumer-driven contracts. Number 4, use emulators and simulators. If you do not need mobile device features like NFC for your app, then physical mobile devices are not necessary to test your app. Use emulators and simulators when you check only functionality, compatibility, and interoperability. There is one thing: if you need more than 10 emulators, I would suggest that you use a mobile cloud device lab. And then number 5, use infrastructure testing. We faced a lot of defects where at the end we recognized that the infrastructure was the reason. Due to that, we introduced infrastructure testing for our cloud environments, Docker containers, and all the other components. So, ladies and gentlemen, I'm at the end of my talk. I hope this talk was valuable, and now I'm available for questions.
Thank you so much, Rudolf. That was indeed very informative and very clear. Rudolf, we have a question from Tarun. Tarun, would you want to unmute yourself and come in? Okay, let me. Yeah.
However, I was able to correlate with the application code and infrastructure testing, which Rudolf explained. But what are the core differences still, if I want to have in one line, between the service and the service integration of the microservices testing pyramid, which you showed, Rudolf? If you can just light on.
Sorry, but I do not understand you.
Let me rephrase that for you, Rudolf. Tarun wants to know what are the core differences between service integration and service in the microservices test pyramid that you showed in the PPT.
What are the difference between service integration test and what was the other test?
And service in microservices test.
Sorry, I didn't catch it. So the question is, what is the difference between
service integration,
yeah,
and service
and service tests?
Yes, in the microservices pyramid.
Yeah, got it. Okay. At the service test layer, we take a look at the microservice self. Yeah, we test all the things from the microservice in isolation. Yeah, with mock dependency. Yeah, and in the service so for instance, yeah, you have a feature. This is the login feature. Your login feature needs 3 different services. At the service test layer, we test every one of these 3 services in isolation. At the service integration layer, then we are testing that these 3 services, which are delivering the login features, are working correct. Yeah, that means these 3 services then communicating with each others, and if necessary to other microservices and to other components which are mocked or not. This depends on your testing strategy. This is the difference. At the service layer, we take a look at one dedicated service. At the service integration layer, we take a look at how the services are working together, which delivering one feature.
Got it. Thank you.
Okay,
you're welcome.
Thanks, Tarun. Thanks, Rudolf. Rudolf, we have one more question regarding the commit in the deployment timeline of 15 minutes. How do we achieve exploratory testing as well within the timelines?
Yes.
This is a question by Vilas Ahuja.
Yes, this is a good question. So, what not was our goal is that we are going to production without manual interference. Yeah. So what we had in our pipeline is that at the end of the pipeline, when we are in the user acceptance test stage, yeah, that we had this break, that we had this stop, yeah, and then yeah, some people get the message, yeah, so please do the exploratory testing. And when I'm talking about exploratory testing, this was not tests like for 15 minutes or so on, yeah. This was only a quick check, yeah, that everything works, yeah, from the human perspective.
Cool. Thanks, Rudolf. Hope that answered the question, Vilas. Rajan, I can see your hand raised. Would you want to communicate? Meanwhile, we have another question, Rudolf. Which tools are used for mocking or service virtualization? Rudolf, you are muted. I think you'll have to unmute yourself.
Okay, can you hear me now?
Yes, we can.
Oh, regarding which tools we are used for mocking in the, so we started with Mountebank, and then we recognized that doesn't fit for our needs, and then we switched to WireMock. And now we are using WireMock for all of our more or less virtualization stuff.
Okay, hope that answers. Yeah, another question, Rudolf. How to perform infrastructure testing and which tools can we use for this?
Okay. So due to the fact that we used EC2 instances, Amazon Cloud, Docker container, and so on, we used a mixture of inspec for verify if our components are configured correctly and that they are running correctly, and we used also what was the other? Come on. Give me 1 second, please.
Sure.
I have to check it. Yes, and then we used molecule for testing the Docker containers. And our strategy for using tools, yeah, is that we use open source tools.
Sure. Thank you, Rudolf. Let me just share my screen here. We do have a couple of more questions coming up, but then due to the time constraint, probably we can have Rudolf answer them or Microsoft Teams. Is that okay with you, Rudolf?
Yes, of course. So tell me where's the chat and I can answer the questions.
Sure. I'll help you offline with that.
Okay.
Thank you so much for that informative talk, Rudolf. We really enjoyed looking at the slides and the pyramid and all your explanations. Thank you so much for being a part of API Summit 2021.
It was a pleasure. Thank you for having me.
Yeah, so glad to have you with us. Audience, please, we will be posting this link. Please fill in your feedback for Rudolf talk and please connect with him offline on LinkedIn if you want to know more about the topic or connect with him. Thank you so much, Rudolf.